in the so to repeat it, in the first step between client and server, client is going to initiate any communication to the server. So the first packet is going to send us, let's talk. Param, I see you something speaking. So is it fine, my audio? Anyone finds difficult? Okay, fine. So that is the first packet the client is going to initiate, saying that let's talk using a TCP sync packet. For that sync packet, the server is going to acknowledge, saying that, okay, boss, I'm free now. Let's have the, let's talk. Okay, talk, or whatever it is. As a reply, he's going to give. Then, as a third step, as I said, client is going to say, okay, great. Thank you for accepting my request. He's going to reply to the server. And he's going to reply using what packet? Probably he's going to use a TCP acknowledgement packet. Using that packet, he's going to reply to the server. Now, once he replies to the server, immediately he's going to ask us, okay, I need you to send some data. As I said, let's not worry about what is that some data. He may ask a web page. He may ask for a file through FTP. He may ask for a, let's say it is a remote login, some communication. Let's not worry about that. So he's going to let's say to keep it a generalized way, he's going to ask saying that I need some data from you. Using which packet he's going to say that? Probably he's going to use a TCP data segment, right? He's going to use TCP data segment and he's going to request. Now, what the server is going to say for that? Once it accepts, see, at the initial stage, it has accepted the connection, then it has accepted the TCP datagram segment. Now it has to reply for that segment. So it says, thanks, I have received your request. He's going to just reply, thanks, your request is received, but he has not served the request. He just says your request is received. Probably in the next packet, if you see, here is your data, what you want. He's going to use again TCP data segment and he's going to reply. It might be one segment or it might be multiple segments, right? It depends upon the size of the data what user has requested, or let's say client has requested. Depends upon the what data client has requested. He's going to say this is your data segment. Then the client is going to acknowledge, yes, okay, fine, I've received your data using an acknowledgement packet. Now, if there is any other data which the server required, or let's say client requires, then the server is going to ask, I'm finished and I have no more data to send, right? And it is going to initiate something called TCP finish packet, or let's say acknowledgement packet. And then the client is going to reply saying that I'm finished as well, thank you. Then the connection gets closed, right? So this is the general process between the client and server. The usual communication happens. So as of now, we are not discussing about any state and stateless, which we have done in the class. Let's keep it as a generalized communication way, right? So he may get one packet or he may get multiple packets. Let's not worry about that. But this is a let's say common procedure or common steps which takes place between the client and server whenever the client wanted to get some data from the server. Now, going further, there is something called packet filtering. There is something called packet filtering. Probably we'll see this slide and the next slide, and then we'll go to the simulation. Only 2 slides from this presentation. Okay. So there is something called packet filtering. Now, what is that packet filtering? Now, if you observe or if you remember carefully, there is one video which I've shown in the class about how the packets will travel from one end to another end. If you remember TCP/IP packet, or let's say UDP packet, right? If you remember that video, you can see there is some filtering happens at a one stage. Now, what is that filtering happens? See, when there are 2 ways. Now, let's say that's what we have discussed in the class also about something called proxy as well as firewall. So there are 2 levels of filtering. Let's take it in this way. Now, one level of filtering happens is my router may say, boss, if any packet is going to the Facebook server, I may not allow at this particular instance. All right. That means it is not taking any packets at all, which are with respect to the Facebook server. So he is trying to filter, saying that, okay, these type of packets I'll not allow. That is one way of filtering. Now, he may say the other way of filtering was, look, Out of 60 students in the class, I may allow only 20 students to reach the Facebook server. Let's say 40 students, I may not allow them to reach the Facebook server because of different policy reasons or some administrative constraints or to save my bandwidth. So it may put some restrictions saying that I will allow only few people to reach. Example, if you have an exam server in our college, so nobody, it is not open for everyone to reach that particular exam server, right? Probably only the faculty or let's say the restricted people are allowed to reach the exam server. So there are sometimes I need to filter the packets, maybe filtering in terms of who is trying to reach that particular server. So that I call it as probably you can take it as I'm not allowing those packets to reach the server. That's where we have discussed something called, let's say, in the part of ACL, which we have seen yesterday. Right? So one way of filtering is I may allow everyone to reach the server, or I may put some restrictions people to reach the server. Now, second type of filtering is, that's what we have seen with respect to the firewall. I may not allow all the packets to come inside my network. I may not allow all the packets. If you remember carefully, I've given an example. Let's say whoever is trying to enter to the JAIN campus, at the entrance of security, I can say there are two types of filters. What is that first filter? I may say filter like your students should not go outside the campus in this particular duration. So incoming packets are not allowed to go outside. Similarly, I may put a filter. Not all the people from outside are allowed to enter into the campus. I may put a filter for incoming packets also. Right? That's basically I'm trying to, let's say, control or monitor or moderate the usage of my network. Right? That is the purpose of the filter. The filter can happen for the incoming packets, or it can also happen for the outgoing packets. All right. So if you see this diagram, probably there is a condition here for which network this particular packet is going. If it is going for a network A, then asking for port 80 services. Now that particular packet might ask for port 80 services. It wanted to communicate through port 80. So there might be two options. Yes, allow for communication or deny. So you can filter in that way. So you allow that communication or deny that communication. If you allow, yes, you are able to allow them to communicate using a port number 80. If you deny, yes, you are saying that no, you are not allowed to communicate using a port number 80. So something like that. So we are going to use the concept called filtering concept. So what is the objective of this filtering? We are going to allow some certain types of communications. We may deny certain types of communications or the source itself. Right? The allow and deny can happen in two ways, right? So the first thing is what I said is allow and deny can happen for incoming packets, as well as the allow and deny can happen for the outgoing packets. Now the second level is this allow and deny can happen in two ways. What is the two ways? Probably I may not allow a particular student, or I may not allow a particular communication, right? Two ways. So I see CS62 raising a hand. Any query? Any query? Any doubt? I see CS62. Frankie, any query? Any doubt? Okay, you have taken off the hand. All right. So broadly to summarize this slide, see the packets can be filtered in two ways. One is you may not allow the packets to go out of your network. Two is you may not allow the packets to come inside the network. So the filtering can happen for the inbound as well as outbound. Right, when the packets are going outside or when the packets are coming inside. So that is a one level you can apply, or you will apply a filtering. The second level you can apply a filtering is you can apply a filtering based on a source ID. That means if I say some XYZ person, I may restrict all type of communications of this XYZ person to go outside the network. So example, if I restrict Vivek, if I point a Vivek, I may say from Vivek, I have two ways of filtering. One way of filtering is all the packets from Vivek has to be blocked going outside the network. That is one way of filtering. The second way of filtering is if I point a Vivek, probably except HTTP request, all other packets can go out. So that is based on a type of communication also, I can put a restriction. So hope you are able to understand the second level of permitting and deny. The first level of permitting and deny is from a Vivek, I'm blocking everything to go outside the network. That is the first level of filtering. The second level of filtering is from Vivek, maybe I may allow only HTTP or I may block only HTTP. Remaining all other communications I may allow or block. So based on type of communication, I'm doing a filtering. All right. So there are two types of filtering here. Now the first way of filtering, I'll call it as a standard access control list. That means you are blocking a complete person, complete source IP, complete device. If you are blocking, I may go with the standard ACL. The second way is I'm not blocking a complete person, rather I'm blocking a certain communications which happens from that particular source or a person. I'll call it as an extended ACL. So whenever I say extended ACL, that means we are blocking a certain communication, not complete source, right? So hope you have got the clarity on what is standard and what is extended. Standard represents to blocking a complete person. All right. Extended represents to you're not blocking a complete person, rather you're blocking a certain communications which are raised by particular user. That we call it as an extended version. All right. Now, if you see this slide, that's okay, Frankie. No worries. If you see this slide, what is an ACL? If we allow or deny to access particular, that's whatever we have discussed now. So now, if you say a router 2, there is an ACL which we are applying as an outbound, saying that allow email and deny telnet. So that means I'm trying to allow the email communications and telnet communications I'm trying to deny. If you see router 1, it says no video for S1. So for the source, it is trying to block the video. All right, the protocols which are with respect to the communications with respect to the video. And it says no access to S1 to S1. So it is trying to block any communications happens from S1 to S1. Yesterday somebody have asked, sir, intranet, can we apply ACL? Now you can see this example, right? So S1 to S2 or S2 to S1 also I may block the communication. Now if you see router 3, it says there is a ACL applied as an outbound, so to access the HR network, right? So I apply ACL here, restricting the people to access the HR, or let's say it as that particular network. Now I may have another ACL applied as an inbound, saying that no updates, no FTP communication, no web communication. So I'm trying to put some more restrictions on the PC3. So basically what we are trying to understand is we can set some access rights or some restrictions on outgoing packets as well as on incoming packets. That's what happens with respect to the ACL. That's what we say access control list. Now this completely 1, 2, 3 with respect to R1, I'll call this as a list. What is this list? This list talks about who has to get the access, who should not get the access. So that's what we call it as an access control. And I'm going to maintain a list. That's what the meaning of ACL. All right. So hope I have given you the clear picture of what is ACL is. So before I go to the simulation, if you have any doubt with respect to the ACL concept, or let's say the understanding of what is ACL, can you just drop me in the chat box so that I can get a clarity that you guys are able to understand, and then I go with the concept. So any doubts with respect to the concept of ACL? Basically, you should need to understand what is ACL, and you need to understand what is filtering, that is outgoing packets or incoming packets, and then you should be able to understand what is standard and what is extended. These 3 points, if you are able to understand, that's fine. So that to go ahead with the topology. Any doubts as of now? Okay, if no, thank you, Aniket. If no doubts, probably I'll go with the simulation. We'll try to configure. So as requested by few students, what I'm going to do is I'm going to reconfigure the standard ACL. Rather reconfigure, I'm going to re-explain the standard ACL. Try to clearly observe probably it may help you to revise or let's say whatever it is. Once we have done that, then we'll go with the ACL, let's say it is an extended version. All right. So to understand the concept of a standard ACL, what we are going to do is we are going to take a normal topology with the two routers. So the first step is, if you observe carefully, I'm going with the generic routers. So I've taken two generic routers, router 1 and router 2. Then I'm going to take two switches. Again, they are generic switches. I'm going to place it one here, and I'm going to place one more switch here. Screen is not visible. Just give me a second. Yeah, just give me a second. I have not shared the complete. Okay. Hopefully now it is visible, right? The whole screen is visible. Can someone text me? Yes. Okay. That's what. So what I'm going to do is, for that, as I said, I'm going to take two generic routers and then two generic switch. Fine. Then I'm going to take some end devices, probably two PCs, and I'm going to take one server. I'll come back why we have taken the server here. All right. We'll come back and understand why we have taken server here. Then we are also going to take, let's say, two other end devices here. One, probably two, and then I'm going to keep one server here. Right? Probably we are going to use two servers. Let's see why are we using these two servers. Then and there we'll try to understand the purpose of these two servers. Right? If we are not able to gain anything from the server, probably we'll come back and we'll remove the servers. Okay. Now let's connect them with the physical interfaces. This is the second step which we are going to do. We're going to connect them with the physical interfaces. As of now, we have not configured. But this is a physical topology we're going to take. So, all right. Then the next step is, as I said in the previous class, I'm going to assume this is 192.168 1.0 network. All right. This complete, I'm going to take it as a 192.168 1.0 network. This will be 192.168 1.0 network up to here for me. Then I'm going to assume this as 192.168 2.0 network. Probably I may configure, let's say, what is that? I may configure here 2.1. I may configure here 2.2. And then I'm going to take this as a 192.168 3.0 network. Okay. So this we're going to treat it as a 3.0 network, probably from here. This we're going to take it as a 3.0 network. All right. This is another network. Probably between there is one more network. So let's configure that physical devices. Let's say I'm going to take this PC and I'm going to say IP address is 192.168 1.1. I'm going to give an IP address here. And the gateway, I'm going to maintain it as a 1.4. Maybe the fourth IP. After giving 1, 2, 3 here, and fourth IP, I'm going to maintain it as a gateway. So that's what we're going to use a gateway. Okay. DNS, let's not worry as of now. We'll come back and we'll set it based on a requirement. We'll set the DNS. Let's not worry about the DNS as of now. So then I'm going to set for this device. I'm going to set it as a 1.2, and then I'm going to say this is your gateway. Then with this device. Similarly, server also, I'm going to set your IP is 1.3, and this is your probably the default gateway. So that's what I said. Now, hopefully, we have not set the gateway. Let's set the gateway also. So what is that? Router. So the router. So I'm going to say enable config terminal interface fast Ethernet 0/0, and we're going to assign the IP address 192.168.1.4. Subnet mask is default subnet mask of a class C. Then we're going to say no shutdown. All right, fine. So hopefully we are done with this network 1. So let's call it as a network 1. So we have done the configuration of network 1. So what does that mean? Well, when we say we have done the configuration of network 1, that means the people in the network 1, they're able to communicate themselves. Let's test that. So hopefully it will communicate. There is no bigger task in that. We can test this. So now packet goes to the router. So using a switch only, need not to go to a router also. So they are able to communicate. So network 1 is done. Now let's quickly jump. Okay. Okay. Let me save this so that it's not. I want to save. I'm going to save this as ACL, probably standard and extended. Both we're going to save. So that, okay. So now let me jump to the concept. Let me jump to the, let's say, second this thing network. So I'm going to go to this router. Then I'm going to get into the interface. Now the interface is exit, probably interface serial 2/0, and the IP address is 192.168.2.1. Subnet mask is going to be again class C subnet mask, default subnet mask. Then, and it is up to again clock rate. Let's go with the clock rate. 64,000. 66. No. Okay, let me go with the 1200. It's not mapping to 1200 also. What is the default for that? I just need to check interface. It's 1200. It's not taking. Okay. So let's the clock rate 64,000. That's it. And I want to say no shutdown. So we have done with the configuration of the serial interface, right? The serial interface is done. Now let's configure the serial interface. So let's go with the GUI itself, but I don't suggest to go with the GUI. I recommend students using a CLI mode so that you practice your commands. So now this, I'm going to say 2.2, and then this, and this is C4. Done. So we are done with this network. We are done with this network. Let's see other network 1.3. Now we are going to configure this PC, saying that 3.1, and we're going to do it here 3. Gateway, we're going to set it as 3.4. Okay. DNS also, let's not worry, we'll come back and we'll set that DNS. We are done with this PC. Let's go to this PC and say your IP address is 3.2. So, and your gateway is going to be 3.4. We are done with this PC. Then we are going for this server. We're going to tell the server again, your IP is 3.3. Fine. And your gateway is going to be 3.4. So this is what we have told to the server. And let's configure this 3.4 interface. So for fast Ethernet, we are going to say it as again, I repeat, I don't recommend configuring using a GUI. I recommend the students to go with the CLI mode. Sorry, 3.4. 4, and this is you. So pretty good. What we have done, we have configured all the networks. That is the first stage. Even now, you can ping a packet within this network. Hope they will be able to communicate. As a second step, what we are going to do is we are going to configure a routing algorithm, because a default route will not work. Even default route, if it works also, it is limited to only directly connected networks. So if I wanted to ping a packet from here to here, the packet may not go or will not go as of now, because no routing protocol has been configured. So for that, what we are doing, we are going to configure a routing protocol. So probably we'll go with the RIP only, and we'll say there is a 1.0 network which is connected to you. This is the first thing I'm going to say to this router. Second thing I'm going to say to this router is there is 2.0 network which is connected to you. All right. Similarly, to this router, we're going to say there is a 2.0 network which is directly connected to you. There is a 3.0 network which is directly connected to you. So we have done, let's say, a routing algorithm also. We are able to send, now we should be able to send a packet between the networks. Let's try and see whether the simulation works fine or not. And we are able to reach from one network to another network. As of now, we have still not configured any ACL. We are just trying to set up our test bed so that on this we can configure our ACL. Maybe the first packet, usually ARP drops the first packet. What is the purpose of ARP? Oh, we have discussed that in the class. Let me send the packet. Yes, the packet goes and come back. That means we are able to communicate within the or between the networks. So this is our first observation. So I repeat the steps. The first step, we have assigned the IP addresses. We have assigned the gateways. Second step, we have configured a dynamic routing protocol. Part of the second step, we have tested whether these protocols are, after configuring a dynamic routing protocol, whether there is a communication happens between these two networks. Yes, we are able to communicate. All right. Now look at the third step, what we are going to do it now. Third step is, now this has been taken as a server. Now I'm going to say, I'm going to ask the server, all right, part of the server, there are different services. The first service is HTTP service. That means I can host a web server. If I make it on, by default, it will be on. What are the web pages I have hosted here? We have hosted, these are the web pages which are hosted. So now I'm going to edit that web page. I'm going to say here, this is network 3 server. This is network 3 HTTP server. This is what we're going to host it. I think I've okay. This is what I'm gonna host it. This is network 3 HTTP server. So that is only the editing we have done in this with respect to this server. Okay, I'm gonna save that. Fine. So somebody tries to access this as of now from this network, from other network. Let's see what happens if they try to access this server. All right. So now I've done this modification. Now let me ask this laptop to ping that web server. So how to ping now? Because I have not used any DNS server now. So I have to ping using IP address only. If I give using, let's say, www.vivek.com, it may not ping because we have not enabled any DNS. So at this stage, I have to ping using a IP address only. Look at this. I'm going to ping now 192.168.3. Probably the IP is 3, I guess. So we're going to ping. Okay, it is in simulation. Okay. we're going to ping using a 3.3. Now you can observe that this is the network 3 HTTP server. That means we are able to ping this web server, which is hosted here from this PC. Very good. Let me try to ping the same web server from this PC, from this network. Let's try, and we are able to reach that web server or not. All right. So what I'm going to do is I'm going to take a browser from a PC port, and I'm trying to ping 192.168.3.3. Yes, we are able to ping using a IP address. All right, we are able to access that web server. That means we can reach this web server from this PC, whatever the PC from the network 3, and also from the any PC from the network 1. As of now, there won't be any problem. There is no problem at all. Okay. That is the third task, or it's a fourth task which we have done. What is the task we have done? We hosted a web server here, and we try to access the web server from this PC. Yes, we are able to access. We are trying to access the web server from this PCs, any one of these fellows, right? We are able to access, right? But point here is we are able to access using the IP address. All right, we have not used any web name or website name because we have not done any DNS server hosting. All right. Now the next step is, as a fifth step, what I'm going to do is I'm going to make the DNS service on, and I'm going to record it here. What is that? I'm going to record it. I'm going to say any request comes with a name called www. This time, let's say vivek.com. All right. Through a browser, right? It has to map to the IP called. This is the IP which we are going. This is the IP which we are going to take. 192.168.3.3. So this is the mapping which we are going to do it. We're going to say add. So anybody browses vivek.com, the record has to be mapped to this IP. That's the duty of DNS. What it will do, it will map the name character to the IP address. How it will map? Somebody has to feed that information before it maps. If the information is not available with the DNS, it cannot map. It blindly says, no, the address doesn't exist. All right. So now, once I map this, I'm going to access from this PC using this time. I'm going to use the, let's say, instead of IP address, I'm going to use the name. So what is that name I'm going to use? www. I'm going to use vivek.com. All right. Okay. It says host unresolved. Why? Did we not enable service? So DNS 192.168.3.3. Okay, it is unresolved, correct. So we are trying to access vivek.com. It says host is unresolved. The reason is this PC doesn't know where is the DNS server exists. That's what in the IP configuration, we have not given any address of DNS server, if you observe here, right? So what is that we have done as of now here? We said DNS has to be enabled and this has to be mapped. Now we need to tell also this PC what is the DNS server. So even the other PCs. So what we're going to do is we're going to first tell this server the DNS is, as of now, the DNS is going to be the same 3.3. That is the DNS server. Okay. And I'm going to tell the same for other PCs also. Boss, look, your DNS server is going to be 3.3. So if any name comes in the browser, you have to send a request to this 3.3 so that he will map and he will give you the result back. Okay. I'm going to tell this fellow also, boss, look, your DNS server is going to be 3.3. All right. Now this fellow knows when I use, instead of IP address, when I use www.vivek.com, what happens in the first stage? The first stage, this fellow will send a request to the DNS server saying that give me the IP address of vivek.com. Then this fellow, as of now, it is in the same. This fellow will send a reply saying that this is the IP address. Now the request goes to that IP address, give me the HTTP web page or whatever it is. As of now, what we have observed is DNS and HTTP hosted in the same server. You can maintain dual server or multiple servers also. It is up to you. Okay. So look at this. Now, the moment I say vivek.com, now the request has gone and it is able to access network 3 HTTP server. So that's our reason, purpose of DNS. All right, that's how the fifth step which we have configured. Now you can see from this PC also, I'm trying to access vivek.com. Right? Yes, the request has gone to the DNS, and then from there the IP has been pulled, and then the request has gone to the HTTP web server. From there, the page is displayed. As of now, fine. All right, within this network, I'm able to reach the DNS server using a URL instead of IP address, using a character or let's say name www.vivek.com. So let me ask this PC also to access vivek.com. As you know, the first stage is it cannot access. It can access, let's say, 192.168.3.3. It can access 3.3. Through IP, it can access. All right. But if you ask through, let's say it as a URL, what is that URL? Probably www.vivek.com. If you try to access using a URL, right, it may say, no, I don't know. Because there are multiple reasons. One, this fellow, first of all, doesn't have any DNS, local DNS. If he has got some local DNS, he can request the local DNS, what is the IP of vivek.com. All right. Probably local DNS will serve the IP address of vivek.com, then the request goes here. Right. That is the first reason. He cannot process this request. Even this fellow also cannot process the request when you try to access using a URL, because they don't have any DNS activated. Right. So for that, what we are going to do is now we are going to set a local DNS server here. Right. That's what we're going to do it. So under the services, right, probably I think this is 1.3. All right, this is 1.3. So we are going to say HTTP, it is on, right? In this HTTP, I'm going to say probably this is network 1 HTTP server. I'm going to say this is network 1 HTTP server. I'm going to save that. All right. I'm going to save that. Okay. So that is the first step I've done. HTTP, we have edited it. Second step we are going to do is, my mobile is, second step what we're going to do is, I'm going to activate the DNS server. So look at this. I'm going to first activate the DNS server, right? And then the first thing I'm going to map is, I'm going to say if somebody www.fet.com or let's say fet.com, then the request has to go to 8 1.local server. No DNS record. Okay. Add. Okay. Then I'm going to feed some more information. If some record comes to www.vivek.com, all right, then the request has to go to 192.168.3.3. That is a web page, or let's say where that particular web server is hosted. Sorry, I'm going to say add. So you can see there are 2 records added. So one about the local HTTP server and the remote, whatever it is. So then next step, what I'm going to do is, I'm going to ask the desktop, I'm going to reconfigure the desktop saying that your DNS server is 1.3. So the first thing you have to approach is, anytime any URL request comes, you approach 1.3 local DNS. That local DNS will give you the information because we have already fed the information here. So that we are going to set it here, your local DNS server, done. And then I'm going to tell these PCs also, boss, look, this is your DNS. So anytime you wanted to retrieve some URL, you first have to request your local DNS. Right? Sometimes it may also happen, I may not have local DNS, I have to send a request to remote DNS. That is also okay. We can see that also an example. Okay, we can do that also, that is also permitted. Right? 1.3. So even for this, I'm going to set your DNS is going to be 1.3. Fine. Now look at from this PC, all right, what we're going to do is this time I'm going to access through a URL or let's say campus. So this time I'm going to say www.vivek.com. What happens first, the moment I say go, the request goes to my local DNS because my local DNS is 1.3. Then the local DNS will pull the IP address and gives me the mapping IP address for vivek.com. And then it will forward the request to the vivek.com to display the page. All right, that's how it happens. Right? If suppose there is no details of vivek.com in the local DNS, this fellow cannot give me the IP address, equivalent IP address. That's where it leads to the failure communication. All right. Okay, let's see that. Now you can see what happened now. The request has gone to the server, local server. Then the local server replied saying that for vivek.com it is 192.168.3.3. Then the request has been sent to the vivek.com. Then you get this page as a reply. You're able to get this network is 3. Say this is network 3 from HTTP server. All right. Now, if I put a let's say www.fet.com, what happens? That is my local web server. So it gives me this is a network 1 HTTP web server. All right. So hope you understood as of now. Still, we have not configured any ACL because we need this test bed to configure the ACL. All right. Now let me take some queries. There are some queries given in the chat box. Let's see. CS002 asks, sir, how to access multiple pages from server? We have given 192.168.3.3 in the DNS server for each PC. But what if we have multiple pages stored in the server? Do we have to change the IP every time for each different pages, or we can put multiple pages in one single IP address and can access a single IP address? Okay, got it. Okay. So any other queries before we go ahead? Okay, thank you. Any other students? As of now, still I say we have not configured the ACL. We have just built or we have just constructed our test bed so that we can configure the ACL and we can test it. And we try to also understand certain points like how DNS works really more in closer way, right? So as I said in the previous sessions, for these topics, I am not spending more time on the slides. Hopefully you understand from the configuration. So if you wanted kind of notes or something, you refer to the slides. Okay. So what about others? If no doubts, can I go ahead with the ACL? Can you just drop me in the chat box? Hope everyone is alive. No doubts, sir. Okay. Okay. There is one more question from CS002. Sir, but one question is still there. Can we give a multiple pages in a single IP address like vivek.com and fet.com? As of now, this simulation doesn't have that provision. It is limited. Yes, it can be given. No, sorry. It cannot be given. For one IP, you cannot give multiple websites. All right. But you can host, let's say, multiple subpages. See, I cannot say for 192.168.3.3, when I access this, it can go to the vivek.com, it can go to the fed.com. No, it cannot be done. It cannot be done. That leads to a confusion. That means you are trying to type the 192.168.3.3, and you are expecting it has to load JAIN website, you are expecting it has to load IRCTC website, and you are expecting many pages to load. No, that cannot be done. So one name will map to the one IP. Probably you can create a sub-records, or sub-records in the sense fet.com/Vivek let's say it as a CS02 or /CSE/ISC. You can create multiple sub-records. Okay. Keshav asked, what does a record imply? What happens if we change it? A record is nothing but a page or information, a log, not a page, a log about a particular IP. So a record is something like, if you see, if I take this server, when I go to the DNS, now a record represents to, this is one log, this is another record. So that is like, I have a two records here. It is like mapping one log from name to the IP. That I call it as a one record. Okay, Nikhil says, sir, can a single site have more than one IP address? No, that's what I was trying to tell Nikhil. No, that cannot happen. A single page, single site cannot have multiple IP addresses. As I said, you are expecting, like, if somebody types JAIN University, it has to load the IRCTC web page also. You are trying to expect in that way. Now, instead of that, what you can do is you can type JAIN University website. Part of JAIN University, you can give a link somewhere inside to redirect to the IRCTC website. All right, that you can do, or you can host it as a sub-module in your JAIN University website. So that can happen. But you cannot expect, okay, well, I'll come back to you, Kesha. So you can, to answer Nikhil's question, you cannot, it is not possible to have one IP mapping to the multiple web records. You can have multiple pages, example, fet.com/index/home or a particular another page, that can happen. But FET, the base name stands the same. So hope I answered your query, Nikhil. Okay, then there is a query from the Keshav. So are there different types of records? No, as of now, we cannot say that is different types of records. Rather, you can say different number of records, right? So this is 1, 2, 3, and so on, n number of records. Now, when you say different types of records, so that goes as a sub record again. As I said, .com or .co.in or .ac.in, right? So that goes as a sub records. So this records represents to the number of records. Okay. So there is one more query from the Nikhil. No, sir, I'm asking, can we access JAIN University through two IP addresses? Can we access JAIN University through different IP addresses? That is possible. Again, that it comes as a load balancing. That is possible. Yes. You can access JAIN University through different IP addresses. That means you have to maintain a second level again. So that's what usually this MNCs, let's say it as a popular websites which are heavily loaded, they try to split in the back end the load. Suppose if I try to access google.com, every time my request may not go to the same IP, it goes to a different IP. Right? That mapping, their local DNS server has to take care. Right? So where they're gonna map it. Right? Because when I request google.com, first time it may go to 192.168.3.3. All right. So the admin would have taken diverting the load. So that goes as a 3.3 IP. Somebody requesting from US, it may go to the 4.4 in their local DNS. Right? So that is possible. That is possible, Nikhil. Is that clear? Is that okay? That my answer is justified, Nikhil? Yeah. So that is possible. So it depends again. Let's say it as the organization structure. As I said, simple example. Google may not route all the packets to the Bangalore web server. Google might have different web servers in different locations. It might take in the backend consideration how to make sure there is a redundant data. But to split the load, it may divert the request to different web servers. That is possible. But for the same IP, I cannot have multiple URLs linking. Example, for 3.3, I cannot link JAIN APT, or I cannot link JAIN, or I cannot link vivek.com. So that is not possible. Any other queries before we go further? Okay, thank you. So let me randomly ask some other people here. Shashwat, are you there? Any queries, Shashwat? So now, if you see this topology, now we are able to reach any PC, any device, any web server across the networks, right? From this PC, I can reach any of these three. Similarly, from this PC, I can reach any of these three. That means reply also I'm able to get from even the server. Even from server also, I can, let's say from this server, I'm trying to ping, let's say www.vivek.com. Okay, spelling is wrong. Vivek.com. Okay, that's true. I'm able to reach. Now, let's see what is standard ACL. So ACL, we're going to see a version called standard. All right. So the first step, what I'm going to do is, I'm going to block, look at this carefully. I'm going to block the complete, any type of communication. I repeat, any type of communication. It might be a ICMP packet. It might be a HTTP request. It might be, let's say, FTP request. It might be Telnet, or it might be TFTP. Any type of communication. Okay, Ritesh says I couldn't reply due to network. No problem, Ritesh. Okay. Okay. Now what I'm doing, I'm trying to block complete access. Any packet rise from this user going outside the network. First step, going outside the network. So I repeat, any type of communication. So any type of communication from this PC, from the PC4, going outside the network. That means I'm going to block it here. Remaining people's communications, I'm going to allow. So I'm trying to set the first level of filter here. What is that? As a inbound. I'm going to set as an inbound the packets when it is coming to the router. I'm trying to filter it here itself. So saying that I will not receive any packets from PC4, and I'll receive the packets from PC5 and server. Right? That is an inbound. That means this router is going to reject all the packets which has come from the PC4. It is not going to take it all. Right? And then it is going to take the packets only from the other devices. That's what we're going to do it first. Let's see how we do that. So for that, what we're going to do is we're going to the router. We're going to say quickly enable config terminal. So as a first step, we're going to create an access list. As I said, access list. Then we have two types of access list. One is standard and one is extended. If I give any number from 1 to 99, by default it takes as a standard. If I give any number from 100 to 199, that will be identified as a extended. So I'm going to use a standard. Let's say I'll use a 50. All right, 50. All right. Now I'm going to set 50 is the access list. In this access list, I'm going to deny What is that I'm going to deny? I'm going to deny 192.168 1.1. So who is 1.1? This fellow is the 1.1. If you see here, this fellow is the 192.168 1.1. So this fellow, I'm going to deny it. Okay. And similarly, I'm going to say access list for the 50 profile. I'm going to permit whom? Any other. Remaining all other people, I'm going to permit. So what is that we have done now? We created a profile called 50, access list called 50. Part of this access list, what is the rules we have set? The first rule we set is we have to deny this. And then we said you have to permit everyone. Now this protocol or this rule, I'm going to apply it here. Sorry, I'm going to apply it at this position as an inbound. I'm going to tell this interface or to this router, you deny this packets from this and permit the packets from this. So automatically what will happen now when I apply it here, any type of communication from this fellow will not be received by that router. So that's what I'm going to do it now. So I'm going to say interface fast Ethernet 0/0. I'm getting into that interface and I'm applying there. What is that I'm going to apply? IP access group 50. I'm going to apply as a inbound, right? As an inbound. Then I'm going to say exit. All right. Now you can see, let us simulate this. Now you can see if I send a packet from this PC to the server, the router, very well, it will permit the packet and you get a reply. All right. Okay. If I'm trying to ping from the other PC, maybe to the server or any other PC, okay, it's gonna permit the packet. Okay. So that's what we said is even in our access list group, right? It is gonna permit. Now I'm trying to send a packet from here to the other server, or let's say the packet goes here. This fellow will reject that and it will send that. So now what happened? The request, what has come, any communication has come from this PC to this server or anybody of this, it is gonna ignore. What about within network? Whether the communication can happen from this PC within a network? Let's see, from this, trying to reach this server. That's what happens because the packet need not to go to the router. Yes, it can get. So what does that mean? When I try from this PC to access, look at this carefully, www.fet.com. So I'm able to get the reply. I'm able to access this web server. But if I try to access www.vivek.com, my router has not permitting or is not permitting me to access vivek.com because it has some restrictions has been applied. All right. So this can be based on IP. This can be done based on a VLAN. It can be also group of IPs. Right. So do you understand that? A standard way, the first standard, inbound. The standard will try to understand the first one is inbound. There is a second one in the standard. There is something called outbound. We'll try to understand that outbound also. Right. So what is that inbound restriction? This is what we have done. Right. Inbound restriction is we applied it in this way. So the packet which is going out will be stopped. Now what packet? Since it is standard, any packet, it represents to any packet going out, it will stop at a inbound. All right. To understand, hope everyone understood this inbound. Can you drop me quickly in the chat box? Inbound, everyone understood? Okay, yes. Okay. Now let's observe one more thing before we go ahead with the outbound. Let's try to observe one more thing. What is that one more thing we are going to do is, I'm going to take a switch as I've done in yesterday's class. I'm going to take one more switch and then I'm going to take, let's say, one more a web server so that we'll understand more easily. So I'm going to connect this web server to the switch, from there to the router, and then I'm going to take this web server or this network as 192.168.4.0 network. Probably I may allocate 4.1 here. I may allocate to the gateway 4.2, right? So don't get confused with this. This is there and this is here. Okay, let's do that quickly. So for server, I'm going to give 4.1, and I'm going to say your gateway is 4.2, and let's say uh, 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 the DNS also will keep the DNS server also 4.1. Alright, that's also we'll do it now itself. So we have done with this, and in the services, and we'll say anybody is trying to reach www.ju.com, right? It has to map to. I'm going to add this, and so the HTTP will from the server is from you server. We're gonna save that. Okay. And the next step, we need to configure 4.2 here. So quickly let's do that also. 4.1, and I'm gonna say 4.2. Fine. And then the third step I'm gonna say is for this router under the dynamic routing protocol, I'm gonna say there is 4.0 network added. So hopefully with this, what I should be able to do, I should be able to ping, or let's say, okay, there is a one more network. As of now, let's try to ping from this PC. Okay, in this PC, let's update also under the DNS services. Under the DNS, let's update. I'm going to update www. If it is fet.com, it has to map to 192.168.1.3. And if it is www.ju.com, it has to map to 192.168.4.1. So that we have added. Let's try to reach ju.com from this side. So I'm typing www.ju.com. The server is from the JU server. So we are able to reach from this side. Anybody, it can be reachable. But as of now, we cannot reach from this side because we have configured here. From this side, what we can do is we can reach JU servers from the other PCs. You can observe that. We can reach JU server, www.ju.com. I can reach JU, right? Okay, there is no information feeded in this server. So let's add that information in this server. If somebody is trying to reach www.ju.com, it has to map to this. Okay, we have feeded that information in the DNS. So if I'm trying to reach from this PC, is ju.com, www.ju.com, it should be able to reach. You can see this PC is able to reach this server. But the same if you try to reach from this PC, www.ju.com, it says no, you cannot reach, because as you understand, we have applied ACL here. This fellow cannot communicate with any other networks outside. So that is the effect of inbound. If I apply it as an inbound, the packets from this fellow cannot be routed to any other place. All right. Now, what we are going to do using a outbound is, I'm going to restrict something like this fellow cannot communicate with this network, but other networks, it should be able to communicate. So slightly, that is the effect of outbound. The moment I make it as an outbound to that respective interface, the packets from this fellow can go to this network, but cannot go to this network. That's what we're going to do it. All right. So for that, what I'm going to do is I'm going to slightly come back and I'm gonna say exit. I'm gonna say interface fast Ethernet 0/0. We have configured an ACL already here. You can look at this here. We have configured in this interface already ACL this way. I'm gonna say here, I'm sorry, we have come out. Configured terminal. I'm gonna say interface fast Ethernet 0/0. I'm gonna say no access, no IP access group 50, which has been configured as an inbound. That means I'm trying to remove that ACL which we have configured here. The profile of 50 still exists, but we have removed as an inbound from this. So the moment you remove, what will happen now? This fellow can communicate now. See, since I've removed this here, I'll try to access from this PC. Let's say vivek.com. Now he should be able to communicate. www.vivek.com. You can see this fellow is able to communicate because we have removed that ACL here. Now, after removing the ACL here, what I'm doing, I'm configuring the ACL here. All right, I'm trying to configure. Is that, I see somebody is playing song. But it's okay. In the break time, we'll hear that song. Let me keep it even as a mute. Okay, now I remove the ACL here. I'm going to configure the ACL here as an outbound and see what is the effect of ACL outbound. Okay, so let me go to that interface. Exit. I'm going to the interface serial 2/0, and I'm going to say IP access group 50 as an outbound. All right. Now, what happened the moment I said it as an outbound here? The router will receive the packets from 1.1. Initially, when it is inbound, it was not receiving at all. Now, it will receive the packets from 1.1, but it will not forward here. It will forward other places. Right? That's what we are going to check, whether that happens or not. So, look at this. Now, look at this. I'm going to keep it in simulation. I'm going to take a packet from this PC and communicate to this server. The packet is forwarded. You can observe. Packet is forwarded. But look at this. I'm going to take the packet from this. I'm trying to reach this server. Because it is outbound, it will not allow. It will send back. Right? So that is the effect of outbound standard, or let's say configuring a ACL in a standard way and as an outbound. You can see that even using a browser also from this PC. You can see from this browser, I'm trying to access www.vivek.com. No, I cannot reach. That, I'm trying to access JAIN.com. Right? Okay, it is in simulation. I'm trying to reach JAIN.com. I'm able to access. I'm trying to reach Vivek.com. You can Vivek.com. It says no, I cannot reach because the packet has been blocked. As a what about Vivek.com? www.vivek.com. You should be able to reach. Yes. but is with respect to ACL standard. With respect to standard, okay, yes, says voice breaking. What about others? Can you hear me? So this is the basic topology which we have taken for configuring the extended ACL. So we have taken 3 end devices connected to a switch, and then that switch is connected to a router. From there, router is connected to a server. Probably in this topology, we have 2 servers. Based on a usage, we'll use the services of those servers. And as I said, we're going to take 192.168 1.0 network here. And then I'm going to take here at this side, I'm going to take 192.168 2.0 network. So that means I'm going to configure 2.1 here. I'm going to configure for the server 2.2. Here I'm going to configure 1.1, 1.2, and I'm going to take 1.3. And here I'm going to 1.4. Right? This is the IP addresses which you're going to configure. Quickly, let's configure that. So I'm going to take this PC. I'm going to say your IP address is 1.1. This is this, and your gateway is going to be 1.4, and your DNS is going to be 1.3. So that's where I'm going to work locally. And for this PC, I'm going to say this is 1.2, gateway is going to be 1.4, local DNS is going to be 1.3. Okay. Then for this server, I'm going to say this is 1.3, the gateway is going to be 1.4, local server is going to be at 1.3 only DNS. And let me enable the HTTP. I'm going to say in HTTP this is probably 192.168 1.0 server. That particular network server is probably going to display it. And in DNS, I'm going to map it to www dot. Probably if somebody types fed.com, then the request has to go to 92.168 1.3. Right? And I'm going to say hi. Right? So what we have done with the DNS here. Then probably this interface 1.0.0, we're going to keep the gateway as 1.4. Say yes. So that means to access www dot, is it APG or some other name? APG.com 192.168.1.3. Okay, DNS service, let me make it on. From the browser, want to access www.apg.com. So you can see you're able to ping the local server. That's fine. Yes, you're able to communicate electrically. So let's configure 2.1 here. 1/1. I'm going to take 2.1. I'm going to say this is the default. And I'm going to say for this server, the IP address is 2.2. Sorry, 2.2. And the gateway is going to be 2.1. And the DNS is going to be again 2.2. Right? That's what we're going to say. So we'll go to the service, HTTP. We'll say this is 192.168 2.0 server. Right? And then under the DNS, I'm going to edit any request. Sorry, is 192, let's say www dot, will map it to ju.com. Somebody browsing ju.com, this will come back. Somebody is copying to ju.com, then it has to go to 192.168, 2.1, 2.1, 2.2. Okay, add. Somebody browses www.fpt.com, then it has to go to 1.3. I added it. Even here, let's add the same about ju.com, www.ju.com, then it has to map to 4.2. As of now, we don't require any dynamic routing because the default route works. We have only one router. All right. So let me access from here, probably www.ju.com, right? It is not able to access ju.com. It will not include the 4.2. Oh, it's not 4.2, it's 2.2, sorry. It's 2.2, sorry. Let me access. Why nobody has prompted it? When I configure 4.2, www.ju.com. Okay, you can see it is 2.0 server. So it is able to ping this. So it's probably like we are able to ping, we can ping anyone to anyone. You can even try from this PC about reaching a JU server, www.ju.com. You are able to reach 2.20 or 2.0 server. Now, no ACL is configured. Everything is fine. Now, I'm trying to configure ACL extended version. Let's see what is that extended version says. So part of extended version, what I'm going to do is, I am going to block probably a ICMP packet going from here to here. So that means, now you can see there is a ICMP packet. We can send a ICMP packet from here to here. You see the packet is able to deliver. So what I'm going to do is, I'm going to block only the ICMP packet going here. Remaining all other traffic should pass on, right? It should go. All other traffic, it should go, right? Except ICMP. So let's configure that. That's what we are trying to configure. So for this PC, we are trying to block only ICMP. All right. All other requests has to go. Look at this. I'm going for the router exit. We're going to say IP access list. This time we're going to say standard, all right? And probably not standard, sorry, extended. All right. We're going to use a term, let's say 120. All right. So I'm going to say ICMP extended 120. All right. Part of this extended, what I'm going to do is now, part of this extended, I'm going to say deny, all right. And I'm going to deny, look at this. These are all the packets I can deny as of now. I'm going to deny ICMP, all right. Host, probably who is that host from 192, 168, from 1.1, right? Going to a host, who is that host? Going to 192, 168, 2.2, all right? And it is the ICMP works on echo, right? You have to send a message and it has to come back. So the echo. Now you can see what I did the part of extended ACL. I said I have to deny an ICMP packet from a host 1.1 to a host, let's say 2.2, and I need to permit I need to permit, all right, to permit host, host IP, okay, any. So remaining all others, we're gonna permit. So we blocked only ICMP from this host going to that host, and we're gonna permit everything. Right? So that is we have done. We're gonna come to the interface post Ethernet 0/0, and we're gonna say ICMP, sorry, access IP access group 120 as a inbound. I think 120 is the one which we created. The group 120 is the one which we create. So I'm gonna do that. Yeah, and I'm gonna say exit. Now let's see what is gonna happen. Right? The first thing, I'm gonna send an ICMP packet from others, from this server to here. I'm gonna send an ICMP packet. So it comes to a router. Router is gonna permit. Okay. I'm gonna send an ICMP packet from here to here. Let me see. Router is gonna take and it is gonna permit. Okay. Now I'm gonna take an ICMP packet from here to here. Right? Router is gonna block that ICMP packet. That is the first test case. Second test case, what I'm gonna do is I'm gonna browse the web server HTTP. That is, when I go browser, it goes HTTP request. It's not an ICMP. Is that basically works on TCP? Right? Is that TCP packet? Okay. So I'm gonna browse www.ju.com. Okay, www.ju.com. Yes, I can reach 2.0 server. What about here? I'm gonna access www.ju.com. You can see I can reach HTTP to JU, right? But not ICMP. What happened now? The ICMP packet has been blocked, but other packets are still we are able to communicate. So now, what is a part of extended says? Extended says if you wanted to block a particular protocol, you can block. That provision is given in the using a extended. Now you can see that. So I'm trying to send an ICMP from here to here. I'm not able to send an ICMP. You can see that also. I'm trying to send an ICMP from here to here. All right. What happens? It says failed. Up to where the packet comes, look at this. The packet comes to up to router because we said to block the ICMP. So it is blocking only ICMP. All other traffic, it is allowing. So you can see that in our simulation. What is all other traffic? We are trying to access the HTTP services from this server. Now, since HTTP works on port number 80 and it also works on TCP, now TCP packets are allowed. Only ICMP is blocked. Now, how do you know that TCP packets are allowed? That's what we are trying to access a browser. www.ju.com. Okay, this is in simulation, in real time. ju.com. We can see the TCP packet is allowed. Right? So that can be as an inbound as well as outbound also, as we have discussed in the standard. Right? So that is the what ACL extended represents to. Extended represents to based on a type of communication you can block. If you refer my slides, you will come to know what are the different types of communications you can block and what is the command like ICMP. You may have to use TCP, like echo. You may have to use the port number 80. Right? Those commands are given in my slides. Right? So that is ACL, extended version. So I hope we are done with ACL. Can I get some doubts? So can you repeat the commands? Your voice was breaking in between. Okay, my voice was breaking in between. The commands for configuring the extended. Is it clear now, my voice, Rishabh? Can I repeat the commands? Rishabh, can I repeat the? Okay, hopefully it is clear. Okay. So now what is that commands I've done is for configuring the extended version. Look at this. The first step, what I did was when I wanted to configure extended version. So I went for IP access list. This time we're going to choose an extended version. That's what we have done. IP access list. Then we have choose an extended version, right? For extended version, the number or ID I have to give is 100 to 199. That will be recognized as the extended version. So that's why we have given IP access list 002. I'll take your doubt once I explain this. Just give me some time. Huh? So so then we have done 120 IP access list extended 120. So once I created extended version, then I'm saying part of this extended version, I'm going to deny whom. That's what we have done here. If you see carefully, I'm going to deny ICMP packet going from host 192.168.1.1 to a host 192.168.2.2. So I'm trying to deny only ICMP. That means other packets has to be permitted. Other packets has to be allowed. Other communications has to be allowed. So that's what we said. Deny ICMP whatever it is, and echo represents to the type of ICMP reply or whatever. Then I said it has to permit. If you come down slightly, we can see here it has to permit any other communications to any other person. All right. So that's what we have done, permit and deny as a part of our packet filtering. Then I applied that into to a particular interface. Where is that? Probably the fast Ethernet 0/0. We applied it as a inbound. Once we apply it as an inbound, now you can see I'm not able to send an ICMP packet this way, but I'm able to send an HTTP packet this way. So that is, in a standard version, we have blocked completely. In an extended version, we have a provision to block a type of communication. So you can give a provision blocking a particular type of, as if we have seen, as we have discussed in the class, I wanted to block FTP. Remaining all other communications I wanted to allow. Maybe I can go with this extended ACL. For a particular user, I can block FTP communications going out of the packet, out of the network. So that's what we have seen an example in the simulation. So hope I've given a re-explanation for Rishabh. Okay. Then there is a query asked by, let's say, CS002. So extended version is only for blocking a particular type of the packet. Are there any other users also for this extended version? There are many other users, but as of now, we are trying to limit our understanding only for this. Right? When we go to the advanced level, there are many other features also. But as of a limited time and the scope of our syllabus, we are limiting our explanation of extended version only to this. So hope I have answered CS002. Any other queries? Okay. Sir, what if we wanted to block a particular PC in a particular network, let's say in 192.168, that we have done using a standard. If you wanted to block a particular PC in a particular network, that we can do using a standard version. That's what we have done in the previous example. So hope I have answered your question 002. Okay. Any other queries? Any other queries? Okay, thank you. So if no other queries, probably we will stop the session for now. If you have any other queries, you are free to ask, probably in WhatsApp or whatever it is. I'll try to address all those things. And as as with respect to your timetable, coming Friday we are going to have a doubt clearing session. Suppose in case if anyone have not still understood any particular topic, in that doubt clearing session we are going to revise it. So it is an optional for the student to attend. If you have any doubts, probably we can discuss it on Friday morning session. We have Friday morning first session as a doubt clearing session. So we'll discuss in that particular session. If you have any doubts or any other things you want me to revise, suppose in case if you have missed the class and if you ask me if you want me to revise, probably in a summary or fast track way, I can do that in a Friday class. All right. So if no other doubts further, probably we'll end the session now. Can I end the session? If no other doubts? Okay. So what we'll do, we'll end the session now. Thank you. Thank you everyone for participating. All right.